Alright, it's been a bit since the last devlog, so I might start doing some sort of a little progress update every now and then. This is going to be kind of technical, but I'm just going to explain some rendering stuff and then some lighting updates. As you can see, I have some shadows going on here, so I'm going to be delving into some details regarding that. It's going to be technical, but there will be pictures, so hopefully that will help a little bit. I'm a visual learner myself, so hopefully you are too. Right now, every chunk is being drawn one draw call. So we have a bunch of different draw calls, one for each chunk. The idea here is to have each thread populate a single draw calls data instead of what we have now. This might be more efficient, it might be faster, but the main reason we're doing it is because we have shadow maps now. We cannot store texture units for every single chunk that is currently in the world because there's not that many texture units. So essentially, this is the reason why we are consolidating everything into one draw call. So this is what we have right now. This is our shadow map. It's giving us some shadows here, and we still have our original lighting coming in, and we changed some of the values a little bit. So in terms of the rendering pipeline, essentially we are rendering the scene twice. One scene is rendering our depth for the shadow map, one is rendering the actual colors and textures and everything. The idea here is that if we do return the data, it needs an additional O of N process to actually put it into a single draw call and patch that data together. So what we want to do is just do that part when I generate the chunk, which would mean we need a predefined area in an array with a predefined size. That's the problem here, however, because the size will change each frame, or the size could change each frame, and we need to be able to, on the next draw call, we need to be able to calculate that, or we don't have to be exact, but we do need to calculate it so there's enough room for everything. I do have a primitive restart, so it's fine if there's a bit of extra room between this data because this isn't even going to get rendered anyway, and it's not gonna hurt the appearance of any other data next to it because we do have that primitive restart. It's just going to look fine, but obviously sending extra data to the GPU that you really aren't using probably is not that efficient. So I think that's a challenge here with this. We need to figure out how to get as accurate as we can with the actual size of this data. And so we probably need to base that on the size of the chunk and how we're rendering the chunk. How many vertexes do we estimate will be in this chunk based on some sort of given information? That will be the hard part, I think. But that's the video. I just wanted to go over some of that stuff because I think it's pretty cool, and I haven't been able to really upload a devlog in a bit. This stuff is definitely has a big learning curve to it, so I just wanted to give a little update.